Dear students, so our first module is over. Now let us discuss the second module, sequence and series. Sequences and series, module second. Sequences and series. So what is meant by a sequence? Sequence of real numbers is nothing but a function from set of natural numbers to a subset of R. Sequence of real numbers is nothing but a function that is from set of natural numbers to a subset of R. So the value of this function are called the terms or elements of the sequence, and it is denoted by this way. This is called this is read as sequence xn. Sequence xn where n fall in n. Sequence xn. So for example, suppose sequence xn equals sequence n means it is the sequence 1, 2, 3, etc. That's an infinite sequence. Sequence xn equals sequence n, that is 1, 2, 3, etc. or set of all. Sequence n equals set of all 1, 2, 3, 4, etc. Suppose sequence 1 by n. What is sequence 1 by n? Where n is a natural number. Sequence 1 by n is this 1, 1 by 2, 1 by 3, 1 by 4, etc. Okay. Like that. What is sequence n square? Sequence n square is 1, 4, 9, 16, etc. So these are the sequences. So sequence of real numbers is nothing but a function that is from set of natural numbers to a subset of real numbers. So the value of that function is said to be the element or the term, and it is denoted by sequence xn in this way where n is a natural number. So you consider the sequence. Suppose consider this sequence b. B equals set to b, 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 etc. Means in that sequence each elements are b. So this sequence is said to be a constant sequence b. Constant sequence. So what is a constant sequence? Constant sequence means if in a sequence all the elements are identical, then that sequence is said to be a constant sequence with respect to that constant. Consider the sequence 1, 1, 1, 1, etc. So this is a constant b. Sequence b means here it is constant sequence 1. Constant sequence 1. So this is the constant sequence. Now come to the property of sequences. Property of sequences means suppose x equals sequence xn and y equals sequence y. Then x plus y. X plus y is sequence xn plus y. X plus y is sequence xn plus y. What is x minus y? X minus y is sequence xn minus y. What is sequence xy? Sequence xy is sequence xn into y. What is sequence x by y? Equals sequence xn by sequence y. Sequence xn by n and sequence xn by y. Sequence x by y means sequence xn by x by y means sequence xn by yn with the sequence yn differs from 0. Okay, for all n fall in n. All of these cases n is a natural number. So these are the properties of sequences. Sequence addition. If x equals xn and y equals yn, then x plus y, x minus y, xy and x by y are defined in this way. Okay. So for you can find out suppose x is a sequence 1, 2, 3, etc. X equals sequence n and xn equals yn equals sequence 1 by n. So what is xn plus yn? It is 1 plus 1, 2, 2 plus 1 by 2, 3 plus 1 by 3, etc. and so on. Similarly, x minus y, xy, x by y, etc. So means if sequence x equals 1, 2, 3, etc. sequence y equals sequence 1, minus 1, 1, minus 1, etc. Alternating sequence. So what is x plus y? Corresponding elements, you can add corresponding elements, that is 1 plus 1, 2, then 2 minus 1, 1, 3 plus 1, 4, then 4 plus minus 1, 3, and so on. So this is x plus y. Similarly, what is x minus y? X minus y is 1 minus 1, 0, 2 minus minus 1, 3, 3 minus 1, 2, 4 minus minus 1, 5, etc. So this is x minus y. Similarly, you can find out x by and x by y. Okay, so this is the definition of a sequence, that is nothing but a function from set of natural numbers to a subset of reals, and is usually denoted by secant xn, where n is a natural number. Okay. Then consider a sequence. Consider a sequence x equals xn is said to be converges to x. Secant x equals xn is said to be converges to x, or limit of the sequence xn. Limit of the sequence xn equals x if for all epsilon is positive, there exists a natural number k falling n such that there exists a natural number k such that modulus of xn minus x strictly less than epsilon for all n greater than or equals k. This is the definition of the convergency of a sequence. Means a sequence x equals xn is said to be converges, or limit of that sequence is converges to a particular point. If a sequence x equals xn converges to some x, that is limit of xn equals x. If for all epsilon positive, there exists a natural number k such that modulus of xn minus x strictly less than epsilon for all n greater than or equals k. Modulus of xn minus x strictly less than epsilon means it is minus epsilon less than xn minus x strictly less than epsilon. That means x minus epsilon less than xn less than x plus epsilon. So that means xn fall in the epsilon neighborhood of x. Okay. So it is means it is epsilon neighborhood of x. Okay. So this is the definition of convergence of a sequence. A sequence x equals xn converges to x, or limit xn equals x if xn fall in the epsilon neighborhood of x. That is another definition of the convergence. Okay. So it is xn x converges to or xn converges to x means limit xn equals x. There is another point. If the secant xn converges to x, that means limit xn equals x, or limit xn equals x means secant xn converges to x itself. Agreed. So if secant xn converges to x means xn fall in epsilon neighborhood of x by using this argument. Agreed. So if a sequence means secant xn converges to x implies and is implied by limit xn equals x means if a sequence has a limit, then it should be converges. If a sequence has a limit, then it is converges. So if a sequence has no limit, then it is converges. Then again, if a sequence has no limit, then that sequence is not converges. Not converges means the sequence should be diverges. So if a sequence has a limit, then the sequence is converges. If it has no limit, then it is not convergent. Then if the limit of a secant exists, then it is unique. If the limit of a sequence exists, then it is unique. Means if a sequence has at most one limit, means the limit of a sequence is unique. How? So suppose let x equals xn be a given sequence. If possible, this x has two limits. Let it be x1 and x2. That is, if possible, we have limit xn equals x1 and limit xn equals x2. Then to prove the uniqueness, we have to show that x1 equals x2. So limit xn equals x1 means, by definition, for all epsilon positive, there exists some k1 fall in En such that modulus of xn minus x strictly less than epsilon by 2 for all n greater than or equals k1. Okay, mark it as 1. Then limit xn equals x2. That means, again by definition, it is for all epsilon positive, there exists some k2. There exists some k2 fall in En such that modulus of xn minus x strictly less than epsilon by 2 for all n greater than or equals k2, mark it as 2. Put a k equals maximum k1 k2. So this result is called for all n greater than or equals k. The 1 and 2 are called. 1 and 2 are called for all n greater than or equals k, where k is maximum k1 and k2. Hence, modulus of xn minus x strictly less than epsilon by 2 for all n greater than or equals k, and mod xn minus x strictly less than epsilon by 2 for all n greater than or equals k. Now consider modulus of x1 minus x2. Consider mod x1 minus x2. Mod x1 minus x2 can be rewritten as modulus of x1 minus xn plus xn minus x2. So it is less than or equals by triangle inequality. It is modulus of x1 minus xn, that is xn minus x1, plus modulus of xn minus x2, that is xn minus x2. So by using this argument, it is strictly less than epsilon by 2 plus epsilon by 2 for all n greater than or equals k. That means modulus of x1 minus x2 strictly less than epsilon for all n greater than or equals k. That means x1, since epsilon being arbitrary, we know that x1 equals x2. So the limit of a sequence is always unique. Means if the limit of a sequence exists, then it has at most one limit. A sequence has at most one limit. That is, if the limit of a sequence exists, then it should be unique. Okay. Now, by using these arguments, we have a result. Let x equals secant xn be a sequence of real numbers. X equals, as a theorem, let x equals xn be a sequence of real numbers. Sequence of reals. Then the following statements are equivalent. First one, here A gives x converges to x, capital X1. That is, x equals this one. So x converges to small x. Part B, for every epsilon positive, for all epsilon positive, there exists some k fall in n such that modulus of xn minus x strictly less than epsilon for all n greater than or equals k. And part C, it is part C, for every epsilon positive, there exists a natural number k such that it is x minus epsilon less than xn less than x plus epsilon for all n greater than or equals k. And part D, when part D, for every neighborhood, v epsilon of x, every epsilon neighborhood of x, there exists a natural number k such that xn presents in, the term xn presents in v epsilon x for all n greater than or equals k. Then the theorem states that the following statements, the four statements are equivalent. These are immediate. Why? here A implies 2 is A implies B. That's immediate. Why? First suppose that x be a sequence, x and be a sequence of real numbers, x converges to x. X converges to x means, by definition, x converges to x means, yes, for all epsilon positive, there exists a natural number k such that modulus of xn minus x strictly less than epsilon for all n greater than or equals k. So, from definition, A implies B. So, again, B implies C. When for all epsilon, B implies C. For all epsilon positive, there exists a k fallen n such that mod xn minus x less than epsilon for all n greater than or equals k, then that implies x converges to x. Why? Because it is the definition of convergency. So, A implies and is implied by B. Okay. Now, B gives C. What is B? For all epsilon positive, there exists a k such that mod xn minus x less than epsilon. That means, then immediately we have x minus epsilon less than xn less than x plus epsilon for all n greater than or equals k. So, B implies C is immediate. C implies B also gives, also immediate. Why? Because when x minus epsilon less than xn, when x minus epsilon less than xn less than x plus epsilon means modulus of x minus xn strictly less than epsilon, or xn minus x strictly less than epsilon for all n greater than or equals k. Modulus of xn minus x strictly less than epsilon for all n greater than or equals k. So, B implies C and C implies B are finished. So, C implies D. Thus, we already proved. When sequence xn has a limit x, then we already show that xn fall in epsilon neighborhood of x. So, reversely, when xn fall in epsilon neighborhood of x, when xn fall in epsilon neighborhood of x means xn presents in open interval x minus epsilon, x plus epsilon. Okay. Xn fall in open interval x minus epsilon, x plus epsilon means x minus epsilon strictly less than xn strictly less than x plus epsilon for all n greater than or equals k. That means modulus of xn minus x or x minus xn strictly less than epsilon for all n greater than or equals x sequence xn minus x strictly less than epsilon for all n greater than or equals k. So that means, as for all, that means or immediately this one. That means we can xn converges to x. So these four statements are immediately equivalent to each other. Agreed. That is immediately followed from the definitions and the definition of convergence of a sequence. The sequence xn converges to x means that sequence xn should present in the epsilon neighborhood of x. So, now, that's a result. Let x equals xn. Let x equals secant xn be a sequence of real numbers, and let x fall in R. X fall in R. If secant an be a sequence of positive real numbers, sequence of positive reals, and with a limit an, with a limit an equals 0, then for some constant epsilon is positive, and for some natural number m, then we have modulus of xn minus x less than or equals c into an, c into an for all n greater than or equals m, then limit xn equals x, then limit xn equals x. That's immediate. Why? Because its proof is in this way. Come on, we have limit xn minus x less than or equals c into an, and limit an equals 0. It is given limit an equals 0. Limit an equals 0 means, by definition, for all epsilon positive, there exists some k fallen n such that modulus of an minus 0 strictly less than epsilon. Modulus of an minus 0 strictly less than epsilon or epsilon by c. modulus of an minus 0 by definition. Limit of an equals 0. Limit xn equals x means for all epsilon positive, there exists a fallen n such that modulus of xn minus x strictly less than epsilon. So by using that argument, it is modulus of an minus 0 strictly less than epsilon by c. Okay. Now, modulus of we have to show that modulus of xn equals x. So it is given modulus of xn minus x less than or equals c into a. C into a. So this means modulus of an minus this one means mod an strictly less than epsilon by c. What is an? An being sequence of positive reals. Mod an strictly less than epsilon c can be rewritten as an strictly less than epsilon by c. So from here it is strictly less than c into epsilon by c equals c into epsilon by c equals c. C into epsilon by c equals c. So epsilon. That means modulus of xn minus x strictly less than epsilon. Modulus of xn minus x strictly less than epsilon for all n greater than or equals k. That means limit xn equals x. That means the sequence x converges to x. That is what we require here. So this is the theorem.